Alright, so now we're doing definition of derivatives. So the derivative of f at x is given by f prime, this means prime, of x equals the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. Now this thing is actually slope of a tangent, and derivative is essentially the slope of a tangent line. So there's some rules and steps to follow when finding a derivative. So number one, let's write the definition, which is that this structure thing right here. Second would be substitute. So substitute the f of x that you're given into this definition. So for example, I'm given 2x and I'm trying to substitute it into this, it will be f. So for every x, you substitute an x plus delta x. So we'll do that in a second. And then third would be simplify the numerator, and fourth factor, and then 5 take the limit, which would just be plug in the thing delta x approaches, and then submit the remaining equation. All right, so let's do an example. So here we got this. So we're trying to find the derivative of this. So we're going to do f prime. So first, step one would be write the definition. X, okay, there's a definition. Step two would be substitute. So like I said, for every x you plug in x plus delta x, so this will be x plus delta x squared plus 2x plus delta x minus just the f of x, which is just x squared plus 2x all over delta x. Okay, and so here it's just algebra, the numerator is just algebra, so let's do some foiling. So I'm gonna go to the side here, x plus delta x plus delta x squared plus 2x delta x plus delta x squared. Okay, so I'm gonna do that, put that in the numerator, and distribute that to 2x plus 2 delta x minus x squared plus 2x all over delta x. And now we just simplify. This cancels with this. See, this combined with this. So what I'm seeing is that this is going to be 2x delta x plus x squared delta x squared plus 4x over delta x. And so now, oh, this is not focused. All right, so since this is in parentheses, this is actually, this does not combine with this. This actually cancels out. So this 4x is gone. It's gone. It's my mistake. Don't forget your parentheses. Okay. So now everything here has a delta x, so now we can just factor that out, 2x plus delta x over delta x. These cancel out. So now it'll be 2x plus delta x, and now this is as simple as it's gonna get. So now we can plug in the limit, which is gonna be 0. So this turns into 0. So now it's just 2x. The derivative is f prime equals 2x. All right, to wrap it up, we're gonna learn how to find derivatives at a point, which is very similar to just finding the derivative. So same steps. First you write the definition, which is slightly different. It's going to be f prime of x equals limit as x approaches c, because c is the point, f of x minus f of c over x minus c. Okay, so let's do an example. So this is our function right here, this is our line, and it's asking us to find the slope at x value of 3. So let's plug it in to this. So it's going to be x squared minus 4x plus 4 minus f of c. Alright, so for this, we have to go to the side here and plug in 3, because this is our c, into this, plug it in there to find f of c. So basically it's f of 3, which equals 3 squared minus 4, 3 plus 4. This will give us 9 minus 12 plus 4. It's negative 3, 1. Alright, it'll give us 1. So, subtracting this is f of c. So we're literally just subtracting 1. All over x minus c. So c is 3, so x minus 3. Okay, now we just simplify the top. X squared minus 4x plus 3, x minus 3. We can actually factor this. That's one of the steps, actually, step 4. So it'll be x minus 3, x plus 1, x minus 3, and then these cancel out. So we're left with x plus 1. And part of the definition is the limit as x approaches c, so x approaches 3. So we plug in 3 for this. Or this is not, I'm sorry, this is wrong. Okay. It's not x plus 1, it's x minus 1. X minus 1, okay. That's my bad, okay. 3 minus 1, which equals 2. So the slope of the line at 3 is 2. So that's our answer. That's a derivative at that point.